The Chorizo Project. In this presentation, we will be investigating the dimensions of an unusual object, a Milwaukee Brewer racing sausage doll. In the Mega Penny Project, you can discover what millions, billions, and trillions of pennies would look like all stacked on top of one another. We're going to discover the same type of thing, but with our chorizo doll in the place of the pennies. How many chorizo dolls pack into a cube that is 1 foot by 1 foot by 1 foot? To solve this problem, we can't simply divide the volumes of the objects. Since we can't melt down the chorizo dolls, we must pack the cube like a moving van. Dividing our cube dimensions by the dimensions of the doll will let us find out how many dolls fit inside the cube. The most efficient way to pack our dolls into the cube is to lay them flat on their back. Our doll dimensions when the doll is laying flat on its back are as follows. Length equals 8.5 inches, width equals 5.5 inches, and height equals 2.5 inches. The length, width, and height of our cube are all 12 inches. We can divide this number by our corresponding dimensions. By doing this, we find that 2 full dolls will fit along the width, only 1 doll will fit along the length, and 4 full dolls can fit along the height. In simpler terms, we can fit 4 stacks of 2 dolls when they are laying on their back. You can look at the images on the right to see a better reference of this. However, we can still fit more dolls in the box. If you flip a doll on its side, its new dimensions are length equals 2.5 inches, width equals 8.5 inches, and height equals 5.5 inches. You can find that we can fit 1 doll on its side between the other doll's feet and the side of the cube. Also, 2 of our dolls can now fit along the height. In simpler terms, we can fit 1 stack of 2 dolls in the box. Now we can take 4 times 2 plus 1 times 2 and find that there are 10 total dolls inside our cube. What would be the dimensions of a cube containing 1 million chorizo dolls? Last slide, we found that 1 cubic feet of space can hold 10 chorizo dolls. By taking 1 million divided by 10, we find that we would need 100,000 1 cubic foot cubes to contain our 1 million chorizo dolls, or in other words, 100,000 cubic feet of space. The edges of that cube would be 46.42 feet long, since the cubic root of 100,000 equals 46.42. An Olympic swimming pool has a volume of 88,000 cubic feet. That total is only about 1/10 smaller than a cube of 1 million dolls, which is pretty close. How much would those 1 million dolls weigh? By using a makeshift scale, we can find that 1 doll equals about the same weight as 6.5 quarters. 6.5 quarters equals 36.86 grams. By taking 1 million times 36.86, we can find that 1 million dolls would weigh about 81,262 pounds. An African bush elephant, in comparison, weighs about 13,000 pounds. If you were to stack 6 of them on top of each other, their combined weight would be very close to the weight of 1 million dolls. How tall would 1 million dolls be if put into one tall stack? For this problem, we will pretend we are stacking the dolls on top of each other's heads. The length from foot to head of the doll is 8.5 inches. 8.5 inches times 1 million dolls equals 8.5 million inches, or about 134 miles. The total driving distance from the Madison Capitol Building to Lambeau Field in Green Bay is 134 miles, almost exactly the length of our 1 million dolls. What area would 1 million dolls cover if laid out flat in a square that was 1,000 objects wide? The width of 1 doll is 5.5 inches. By taking 5.5 inches times 1,000, we find that 1,000 dolls laid side by side would span about 458 feet. A square has identical sides, so both length and width are 458 feet. To find the total area, we would multiply length and width to get about 210,000 square feet, or 4.82 acres of total area. The Kennedy Center, a performing arts center in Washington, D.C., spans 4.2 acres in total area. This is rather close to our total area of 4.82 acres. How many school buses could be filled with 1 million dolls? One school bus measures 9 feet by 11 feet by 41 feet. We can multiply these 3 values and find that one school bus contains 4,059 cubic feet of space. We already know that 1 cubic feet of space can hold 10 dolls. So we can take 4,059 cubic feet times 10 dolls to find that 40,590 dolls would fit in one school bus. 1 million dolls divided by 40,590 equals 24.64 school buses filled. The area of one school bus equals its length times its width. Its length times its width would equal 369 square feet. 369 square feet times 25 school buses, which is the amount of school buses we would need to contain our $1 million, equals 9,225 total square feet. So, if we were to design a parking lot for 25 school buses, we would require a lot with at least 9,225 square feet of area. If we stacked $1 billion to completely cover a football field, how tall would they be? First, we must find out how many dolls are needed to cover a single layer of a football field. The area of a football field can be found by multiplying its length by its width. This gives us an area of 57,600 square feet. The area of one doll is 46.75 square inches, or 0.32 square feet. 57,600 square feet divided by 0.32 means we have 180,000 dolls needed to cover a football field. By taking 1 billion divided by 180,000, we find that we would need 5,556 layers of 180,000 dolls. Finally, to find the height of the stack, we simply multiply the amount of layers by the height of a doll. This gives us a total height of about 1,157 feet. If put into one tall stack, how tall would 1 billion dolls be relative to the Earth, Sun, and the Moon? Once again, we will pretend that each doll is standing on each other's head. To solve for the height, we will take our 1 billion dolls and multiply them by their individual height, 8.5 inches. This gives us a total height of about 8.5 billion inches, or about 134,154 miles. The circumference of the Earth at the equator is 24,901 miles, so the length of our stack is about 5.5 times bigger than that. A stack of dolls would also reach about 3/5 of the way to the Moon. It would only make it 0.14% of the way to the Sun, however.